I want to talk about the issue of world population growth, but I want to do it through the lens of the mean value theorem for definite integrals. And the mean value theorem for definite integrals says that if f is a continuous function on the closed interval ab, then there exists some number c on that same closed interval such that f of c is equal to the average value for f, which we call f av, and that's 1 over the length of the interval times the integral from a to b f of x dx. And so if we want to think about this, let's talk about world population growth in billions of people. And there's a formula for that, and it's really a formula for exponential growth. And so we have p of t is 1.43 times e to the 0.01 t. Here t is years, in this case since 1900. And then the question asks us, what's the average population size in the 20th century, so between 1900 and 2000, and when was this value attained? So the time at which it's attained is the value of c. That's going to satisfy the mean value theorem for definite integrals. And so let's work out p average to start, because we're going to need this. So p av is going to be 1 over 100, integral from 0 to 100, 1.43 e to the 0.01 t dt. And we can pull out the 1.43, and then we have the integral from 0 to 100 e to the 0.01 t dt. And so we want to take the antiderivative of this quantity here and then evaluate it between the endpoints. And so this is 1.43 over 100. And then we take 1 over 0.01 e to the 0.01 t. And that's evaluated between t is equal to 0 and t is equal to 100. And so you'll notice these two guys cancel right away, which is really nice. And so then we have that this is equal to 1.43. And then we have e to the 0.01 times 100 minus e to the 0.01 times 0. Okay, this quantity here is going to be e to the 1, and this is going to be 1. And so this is equal to 1.43 times e to the 1 minus 1. And so that turns out to be 2.457. Of course, that's in billions. And so that was the average size of the world population in the 20th century, considerably less than it is right now. And now we want to go to the second part, and we want to find the c such that p of c is equal to p average. So if we write p of c is equal to p av, and p av is 2.457, then we look at our formula for p of c, and so this is equal to 1.43 e to the 0.01 times c. And so we want to solve this equation for c, and then we'll know what year it is, where the world population size was equal to the average population over the 20th century. Okay, so let's go ahead and do that. I'll just rewrite it out here so it's nice and clear. 1.43 e to the 0.01 times c is equal to 2.457. We want to solve that for c. And so the first thing we want to do is divide both sides by 1.43. So we have e to the 0.01 c is equal to 2.457 over 1.43. And the next thing we can do is take the log of both sides, because the log is the inverse function for the exponent. And so we're going to get 0.01c is equal to the natural log of 2.457 over 1.43. And then finally, we divide both sides by 0.01, or we multiply through by 100 equivalently. And so c is equal to 100 times the natural log of 2.457 divided by 1.43. And if you put that on the calculator, that turns out to be 54.13 years. So if we want to go back to the question as to when was this value attained, it would be in the year 1900. plus 54.13 years, which is going to be approximately February or March of 1954. So that's when the average value over the entire century was attained. Pretty cool, huh?